Hello and welcome. Thank you for being here. Thank you, organizers, for having me at this wonderful conference. What I'm going to talk about today is the technology called mixed reality and the device that runs it, which is called HoloLens. And let me first introduce myself. I'm Rafal Legiedz. You can find me on Twitter at Rafał. And I'm a software engineer working for a consultancy company called Solidbrain. It's based in Kraków, Poland. And what I do for the last 6 months is I'm focusing on this AR experiences, holographic experiences that you can get with HoloLens. And basically I'm exploring the possibilities. I'm talking with different businesses to see on which fields can we employ this technology. Also, I'm a conference organizer. I organize a DevConf since 2011 in Kraków as well. And I try to be a conference speaker, so whenever I think I have something interesting to say, I apply to conferences, and hence I'm here, for example. So, HoloLens. How many of you have heard about this device? That's what I thought. How many of you actually tried the device? Quite a few. So I have the device with me, so after the session, whoever would like to try it out, I'm willing to help you out with this. So let's do a quick introduction to the device itself. It's, as we can see, everyone was raising his or her hand because you know the device already. And that's true because the device isn't like very new. It was announced in, I guess it was late 2015, then it was released in early 2016, and the first wave of devices was sent to developers in June 2016, as far as I remember. So it's been a while since it's on the market, and there are a lot of companies already and developers that are embracing this technology, creating lots of wonderful applications. But it's mainly targeted to business, I would say. It's not like mainstream, it's not for consumer markets, so that's why it's not that much visible to like regular users, I would say. Long story short, it's a very sophisticated AR device. Basically, you put it on your head, fire up the application, and all of a sudden you can see like the digital stuff around you. And by the sophisticated device, I meant that the digital content that is being rendered by this device can really blend pretty seamlessly and well with the user environment, which we'll see in a second. So you might have heard that like this year and last year, there's a lot of stuff going on in the media or the internet about AR, VR, that 2017 is the year of VR, etc. And you might be a little bit confused what's AR or VR or what kind of devices we have on both fields, how do they differ, etc. And where the HoloLens is being placed in this group. So having those two realities, like the physical one, the one that we are interacting with every single day on our daily basis, or at least I hope we're interacting with physical reality all the time, and the digital reality, we have in between a whole spectrum of different experiences that we can have depending on the device and depending on the software that runs on those devices. So current AR devices lays very near to that physical reality end of the spectrum, and that's because most of the AR solutions right now are basically run on smartphones or tablets. So the user holds it in his hand, and basically whatever the device can see through the lenses, it's being displayed on the screen, and then the digital content is being overlaid on that screen. So basically there's no immersion effect for the user. The user is still fully aware that he is in the physical environment, and it only looks at some kind of screen with digital stuff on it, and it interacts with this stuff by touching the screen. So no immersion effect, I would say. Some of the devices are a little bit more sophisticated, like for example Project Tango from Google, where you have this special phone, like Android phone, but the phone has like some special sensors in it, so that this device can get a little bit more understanding of the environment, so that it can deliver a little bit more kind of immersive experience to the user, because the stuff that we can play with on that AR device can blend with the environment better than on the other devices, but it's still not the same as in HoloLens. Also, we have those AR solutions, wearable AR solutions like Google Glasses, for example, or Epson Move Area. Those are smart glasses that basically you put on your head and have your hands free. But the digital content that is being rendered there, on the other hand, is totally detached from the user's environment. I mean, it's basically some text or images floating in front of the user eyes. So it's okay-ish, but it's still not the kind of augmenting the real world. It's basically some digital content in front of the eyes. On the other hand, it's worth mentioning that most VR devices, experiences that we have right now on the market, and I mean like HTC Vive, Oculus Rift, PSVR, etc., they live on the other side of this spectrum. And I don't know how many of you tried the regular VR headset, like Oculus Vive or Oculus Vive, yeah, or PSVR, so many of you. So you already know that those experiences are like very immersive. I mean, whenever you have this headset on, you're basically out of the real world and you're fully immersed in that virtual environment, and you have basically no sense of whatever is happening in the real world, right? And you can also see all those funny VR prank videos on YouTube where someone is playing a VR game and the other person is poking that person, and the person playing is freaking out because something is going on that is not in the virtual reality, which is funny and a little bit scary, of course, but it's true. I mean, the VR experiences that we have right now, they are totally like in this direction. So where is HoloLens then? HoloLens, as I already mentioned, is a sophisticated AR device, so obviously it lays on this side of spectrum. It's more sophisticated because it's packed with all kinds of sensors. It's also a head-mounted display, so the user can go hands-free. The lenses are optical see-through, so there is no occlusion when it comes to the user vision, so the user can still experience the real world, but this real world is enhanced with digital content which is rendered here and there, and it blends pretty seamlessly with the environment. So it's nothing more like whatever we have in terms of AR on the market, and in my opinion there is no competition at the given moment for HoloLens. And when it comes to VR, it's worth mentioning also what Microsoft is doing recently is that they recently released the whole set of new VR headsets. They partnered with companies like Asus, Acer, Samsung, Lenovo, Dell, etc. And they released new headsets, which are basically like Oculus and Vive, the regular headsets that you connect to a PC, and you can play games or run applications on it. But the thing is that they employ some technologies from HoloLens to those VR headsets. So, for example, with Vive and Oculus, the thing is that you need external sensors to track the user's movement. I don't know if you remember when you were trying the Vive or Oculus, but you have to have those external sensors, 2 or 3 for Oculus and 2 satellites which are put above the user with Vive. And this is something that makes the user play space area really kind of small and not that extensible, I would say. But with those new headsets, the inside-out tracking from HoloLens allows the headset to track itself, so there's basically no need for external sensors. You basically plug it in to your computer, do a quick setup, and that's it. And the whole spectrum is being called mixed reality, and that's the term that Microsoft is using a lot recently. You can hear it a lot, but it's not the term that is being made up by Microsoft, because that term appeared in some papers like 30 years ago or something like that. Because the whole spectrum is also known as virtuality reality continuum, and this is something that scientists were working on like for several years already. But the thing is, I think that what Microsoft is trying to do here is they're trying to close this gap. They're trying to deliver a set of devices, or maybe one ultimate device that would be able to eventually deliver all kinds of VR or AR experiences to the user. So those are really interesting times we're living in. So let's go quickly through the specification or maybe technical details of the device. It wouldn't be possible to deliver this kind of experience to the user without all kind of sensors, and HoloLens have them all, I would say. I mean, the most important ones, in my opinion, are those two, which are environmental understanding cameras. Basically, those sensors are responsible for gathering user surrounding data. They're scanning the environment all the time whenever the HoloLens is turned on. Also, it has HD camera, ambient light sensor depth camera, mixed reality capture camera, and an array of 4 microphones, so that it's possible to issue voice commands to HoloLens, and as developers we can handle that and operate in our applications with voice commands. And other thing is the optics. I already mentioned that it's optical see-through lenses. There is no occlusion effect when it comes to user's vision. The thing, every eye is being powered by an HD engine, so that means it's more or less 1200 by 700 pixels per eye. But when it comes to HoloLens, we don't describe those lenses in terms of resolution as we might know from the regular screens, because we do not have to fill the whole vision with pixels, because that's what real world is doing. We have all the pixels rendered, right? We have to only render some extra pixels, right? The holograms. So when it comes to HoloLens, we have something which is called holographic resolution, and that means how many light points, and by light points I mean points that build up holograms, how many light points can the device render at the given moment, and that number is 2.3 million light points. Also, we have something similar to DPI from regular screens, which is called holographic density here. That means how many light points per radian can be rendered, and that number is 2.5K. Also, we have the holographic processing unit, in short HPU. That's basically the customly designed chipset. It was done by Intel as far as I remember. And this unit is responsible for processing all the sensory data. So whatever comes from the sensor goes through this coprocessor, and then after being processed, it's being used by the other ones. And also it processes user gestures, for example. So all this technology, I'm not going into details here how much gigabytes of RAM or whatever Bluetooth it has, because I mean that's basically a mobile phone, I would say, right? It's not that important here right now. So given all this technology and the software, and the HoloLens actually run Windows 10 on board, so it's well-known platform, I would say. Developers already created all sorts of good solutions for HoloLens. So let's just name a few, the ones that I like the most, and actually for all of them you can find a YouTube video explaining in details on what are those projects about. The first one is from a company called Citi. It's a banking company where the user can have financial data rendered in front of him and play around with this data, dig through, render some holographic 3D graphs based on some data. The other one is from Ford. They recently announced that they started using HoloLens for the designing process, so that the design process is enhanced with holograms. And here we can actually see that there are 2 persons using HoloLenses, and they're looking at one piece of hologram, and that's one of the features, one of the cool features of HoloLens, where basically we can have one application that is being run on both HoloLenses, and they can share the holographic space, so that users can actually work on kind of inside one applications, which is really cool for collaboration. Also, one of my favorite solutions, this is something I'm focusing on right now as well nowadays, it's from Schneider Electric, where basically it's a maintenance applications for service worker. So whenever the service worker is about to do some work on a piece of machinery, whenever he has a HoloLens on, he can have some digital content overlaid over that machine so that some steps can be displayed or some extra information can be displayed, or the screw can be shown or highlighted which screw has to be unscrewed, for example. So this is pretty cool for maintenance work. As well, ThyssenKrupp company, the company that produces elevators, as well has this application for service workers. Whenever the worker has some job to do at the elevator, he can have all the context information he wants just in front of the eyes. And for example, he can have service manuals, some tutorial videos, can have Skype, he can perform a Skype call to someone else's showing what he's seeing. He can have like a 3D model of the thing that he's about, the thing that he's going to work on, and can explore it a little bit deeper, but on the 3D model. So those are all cool applications in my opinion, and there are lots of them, of course. And but those applications we can see here, they do not use HoloLens to full extent, and by full extent I mean they do not use the coolest feature in my opinion. Basically, that means spatial mapping. Spatial mapping is this feature of HoloLens where, as developers, we can make use of all those scanned, all those data that comes from the scanning process of the HoloLens. So basically, whenever the HoloLens is scanning the user's location, all the data is being stored on HoloLens in special buckets, I would say. And then as developers, we can build up the whole mesh of the location inside our application. So basically, here we can see like the mesh of the room. I know you can't see like a lot, but basically it's a mesh of the room where mesh mimics all the real surfaces. And here is in Unity, here is the material applied, which is this white wireframe, so that we have the visualization. But what I mean is that we can have the real room inside our application, and we can do all kind of cool stuff with it. And the coolest thing lays under the hood. That means colliders. Those are regular Unity colliders. That means this is those are the pieces that makes all the physics possible inside Unity engine, and Unity is the engine which we used for HoloLens development. So basically, wherever we have regular real-world surfaces around us, we have pretty well aligned colliders everywhere. So if we would have, for example, a holographic ball inside our application, and if we would like to bounce it on the floor, then we can detect that the ball is actually hitting the collider, which is aligned with the floor. And we can do all the same stuff with walls or sofas or chairs, etc. So based on that feature, we can create all sorts of even cooler scenarios, like those games that come from Microsoft and Asobo Studio. One is Young Conquer, where we have this little guy that is running on our floor, jumping on our bed, chairs, or table. We have this game, which is called Fragments, the best game on HoloLens in my opinion. Basically, it turns your room into a crime scene, and you're a detective trying to solve this some kind of mystery. And basically, you have the clues that are being hidden in your room, so you have to look for them, like on the walls, in the corners, behind the desk, or your sofa. This is pretty cool. This is the best immersive effect, AR effect I've ever seen, actually. And you have all those holographic persons that actually walk into the room and they sit on your sofa. That's really cool. That's mind-blowing, in my opinion. Also, we have Roboraid, where there's this alien invasion, and actually the aliens drill through your real walls, and like here, and they attack you, and then you shoot them, and when you miss-shoot them, then you're making holes in your real walls. This is amazing as well. I mean, totally awesome. So how do we use HoloLens? How do we interact with it? How do we issue commands? So we have this paradigm called GGV input, where GGV stands for gaze, gesture, and voice. So gaze is basically something like this, I would say. Like if we would have a laser ray from our forehead, and this is the main way how we indicate what are we going to interact with. So basically it's the same as the cursor on the computer, right? We first indicate something and then we invoke some action like clicking. So this is the cursor basically. In applications, wherever our ray from our forehead hits the surface, whether it is like a real surface or a 3D object, we have a cursor that is rendered in that place. The other thing is gestures. So the same as we can do on the computer, like indicate something with the cursor and then click. Here we have also a click, but this click we're performing in air, like air tapping. It's something like that. And based on that gesture, we have some other gestures, like hold, which is like just holding your fingers together. And based on holding, we have like manipulation and navigation gestures, where we can basically track our hand movement, and there we can do some operations based on that. And there are no other gesture. I mean, there is one other gesture which is bloom, but this is like operational system level gesture which we can't use in our applications. So no other gestures. We can't define our own. We have to live with that, but that's more than enough, I would say. The other thing is voice. So we can basically issue voice commands, and as developers we can program for some keywords detection, and based on that keywords we can perform some actions. So basically with this paradigm we can look at something, issue a voice command, or just air tap or manipulate the stuff, whatever we like. So that's how we interact with stuff. So let's go to tools. The most common way to program for HoloLens is by using Unity, which is well-known game engine, I would say, and Visual Studio, which I probably don't have to introduce to you. So starting from version 5.5, as far as I remember, Unity introduced full support for HoloLens. So we have this namespace there called Unity Engine XR WSA, where all the classes that are helpful for HoloLenses live. And we can just use Unity, pure Unity, to Unity and C# scripts for creating the HoloLens applications. But community came to the rescue, and there was a lot of work put into one particular library, which is called Mixed Reality Toolkit, which came from Microsoft, and they open source it. It's a combination of scripts, objects, shaders, materials that you can use in your Unity projects that help a lot while starting with and producing HoloLens applications. And some of them are pretty cool because as we've seen the games earlier, the Fragments game and Young Conquer, so the studio, Asobo studio that was working on those games, they did lots of work regarding spatial mapping and detecting different surfaces in our area, and it all has been released as an open source, and it lives in this toolkit. So it's pretty cool. We can use all of that. And I will actually, we have some time still, so we'll actually go through real quick on how to make use of the things from Mixed Reality Toolkit in a second. The other thing is Mixed Reality Design Labs. It's basically a set of, it's also open source, it's a set of applications by Microsoft. Well, those are different applications. I mean, it's like Lunar Lander or something like that, but they are well documented and they are on GitHub. It's open source, and you can make use of them or learn based on them or reuse some components that they're using in those games. So this is this set of modules, I would say, is really helpful whenever you would like to do HoloLens application. So let's now switch to Unity, I think. And let's do like a really quick Hello World application for HoloLens. I don't know how many of you are familiar with Unity. Does anyone? Okay, so not many people. Okay. So I will explain some bits. but we'll not go to much details with that. So that's basically, Unity is an engine and also an IDE, because Unity comes with an editor where, oh, come on. Okay. Let's just create some weird stuff. We're creating a project, and then the editor will show up in a few seconds, I guess. I don't want this. Okay, it might look a little bit scary if you haven't ever did any job in 3D programs or anything like that. So long story short, it's like we have a scene view here where we put up our scene. We have an inspector here on the right, where basically it's the same as like properties pane in Visual Studio. So whenever we select some object, we can have properties of it here. We have a hierarchy here, so it's like the hierarchy of objects in our game or application. And we have a project pane where we have all the assets that we have imported to our application. So first things first we will import this mixed reality toolkit. I've already downloaded it. It comes in the form of Unity package. So basically, we import that package into Unity editor, and it's decompressing and probably checking something, and it will show us what are the contents of that package. So we have here all important stuff like build helpers, some cross-platform stuff, helpers for input, etc., etc. We don't care right now which we would like to import or not. Let's just import everything. We'll just make use of several of them. I'm going to show you that we can create like really simple application, like a cube which we can click by basically putting some pieces together and writing like one line of code or something like that. So it's like super easy to start. Hold on. Yes, it's importing. So the very next step would be to set up all the properties, all the necessary properties inside the Unity editor, so that the Unity knows that we are creating applications for HoloLens, because that's not the default, obviously. So I could go through all the menus and inspector panes and selecting all the necessary details, but that would take some time. But what Mixed Reality Toolkit developers did, they created some scripts that can automate that process. So what I basically will do is I will just select one option in the menu. As soon as the hold on process will stop. Come on. Come on, come on. We're almost done. And done. Okay. So we have this toolkit imported here. It was called Holo Toolkit not that long time ago, but they renamed it into Mixed Reality Toolkit. So we have all the necessary stuff here. But first, let's configure the. Let's first save the scene. That's our scene. That's important. And let's first configure our development environment for HoloLens. And with Holo Toolkit, it's basically one click, apply HoloLens project settings, and bam, we're done. I mean, what it's doing is basically enable VR. It's setting the quality to fastest. It sets the build target for direct 3D and setting the target also to be the universal Windows platform application. So that's all it does. We need the reboot, and after it's done, we're almost. Okay, we don't need that one. Okay, then we can start putting together the application. We have main camera, that basically camera in 3D engines is basically the camera for whatever the user will see. We need to delete that one, and Holo Toolkit or Mixed Reality Toolkit comes with its own camera, which is already set up for HoloLens development. And what we do is basically we can drag and drop the HoloLens camera here. We can see all the details in the inspector pane. I'm not going to go through all of them or any of them because that would just take a lot of time and wouldn't be that necessary. Also, we have something which is called Input Manager. That's basically a set of scripts that are responsible for the user interactions. They all wrap the scripting API from Unity, and they make a lot of things way easier, which I will show you in a second. Also, in the cursor, which is somewhere there, as you can see, I'm not writing a single line of code, and I have some kind of application right now. And then I will create a simple cube right in the middle. And that cube by default is in the size of 1 by 1 by 1, and that means 1 meter by 1 meter by 1 meter. So let's change it to like 20 centimeters each. And let me just do a quick setup here that we are building for HoloLens, and we can run this application inside our Unity project. And what we have here is I'm using my keyboard to move in the application, and that's actually the feature that comes with HoloLens camera, so that we can move here like in the games. So what we see here is that we have this box. We can walk around it, and wherever we have our gaze crossing with the object, we have this cursor rendered. And whenever we do not cross anything, we just have this blurred dot that indicates that we are not hitting any surface. So that's some kind of a pattern, I would say. And well, let's do something that would actually be some kind of an interaction. So let's do like a click on that box, and let's see how easy it is to be done. So what we will do is whenever we'll click on that box, I will make the gravity being applied to it so that it will just fall down, right? So let's first add something which is called Rigidbody to this object, and Rigidbody is basically a component which whenever you add it to a 3D object, it will start behaving like a physical object. So you can have all the physical interactions with it, and one of which is the gravity. And I will turn it off so that the gravity wouldn't affect that object. And also I will add a script which we'll name cube behavior. Bam. Create an ad, and we'll edit that script in Visual Studio. And the thing is that in Unity, like in any other game engine, we have scripts that are being run in a game loop. So in this case, we have in every script we have the update method, and that method is being run 60 times per second. And that's it. So that's something different than what we are doing, for example, in regular enterprise applications. So we have this one script attached to, and this script is going to be attached to our cube. So whenever the cube is rendered, the update function, which is here, maybe I'll make it a little bit bigger. This update function is being run 60 times per second. So writing applications here is a little bit different than what we're doing in enterprise stuff, for example. But what we wanted to do is handle the clicking. So I could go to scripting API from Unity and look for all those events that I have to listen to and all that stuff and set it up. But what what Mixed Reality Toolkit does, they wrapped it up and they provide simple interfaces that we can implement to handle, for example, clicks. So handle the clicking would be as simple as implementing the interface called input_click_handler. Let's import the whole toolkit and implement that interface. So that's it. So whenever we click that box, I mean air tap on that box, this method will be invoked. And what we would like to do here is apply gravity. So we are getting this rigid body component from our object, and we basically rigid body, use gravity, true, bam. Let's go back to our application and let's run it. We have our box here. Let's click on it, bam, and it fell down. And we can't see it, and as we can see here, it's like falling to the void, like all the way down, all the way down. So yeah, so that's the problem. So we would like to have a floor here in our Unity project. So, and this is the HoloLens application. So the floor is actually being generated like in the runtime, right? We don't have this floor here. So there is this one little trick that I really like, so that there is no need to have HoloLenses all the time with you for debugging, because that would be tiring. To have a floor, I mean, that would be tiring to put HoloLens on just to have a floor and test if the box is hitting the floor. So let's just start using spatial mapping here inside Unity and see how we can emulate some kind of a room inside Unity project. So it's as easy as the other things we did. Basically, we grab spatial mapping prefab, which is similar to what we did previously. And the spatial mapping prefab here, the thing I just dragged and dropped, is also something that wraps whatever is in scripting API for spatial mapping. We can adjust, for example, numbers of triangles for the mesh that we are creating, right, for the spatial mapping mesh. But we're not going to play with those values here. So this is the spatial mapping. The other thing we need to do is go to project settings and select the capability of the application, so that if we would run it on HoloLens, we'll let user know that it requires spatial mapping capability, that we are going to use in our application the spatial data that is being stored on HoloLens. So as simple as that, we have the spatial mapping capability, but still we do not have this room anywhere here. I mean, what I just added would just work, but when I would run it on HoloLens, because there with this spatial mapping module that I added, all the data that is being stored on HoloLens about the current location would be used, and there we would have this floor. But still, in our Unity editor, we do not have it. But there is this fun trick, and the cool thing that was delivered in Mixed Reality Toolkit is that inside the spatial mapping module, we have Object Surface Observer. And here we can provide a room model. And that basically means, hold on for a second. Come on. That basically means you can have room model in like a separate file, and that file can be created actually by HoloLens, because we can connect with HoloLenses and grab the current scan currently scanned location, I mean the location we're in at the moment, and we can export it to like a file with a 3D model. And that model can be imported in Unity. I'm going to import it. That's a regular OBJ object. It's just a regular object that you could create in Blender or 3D Studio Max. As we can see here, like the small thingy, it's a 3D object of some room that I scanned. And what I will do is basically I will attach it to my room model, and then I will run it again, and bam, we have the mesh of our room. Ta-da! And we have all the colliders here, as I explained earlier. So basically, where is that box? Okay, so it's outside of the room, so we can tweak it a little bit, and we'll just move it maybe a little bit inside that room, because well the object is created in 0.000 in this space, and 0.000 is wherever we fire the application on HoloLens, and wherever the user's head is, that's where the coordinate system will be zeroed, I would say. Well, so okay, oh no, not this way, that way. Okay, so here we have the box inside our room, and then we can air tap on it, and it's on the floor, right? So right now we can disable the mesh, that white thingy, and we will still have that box, no mesh, but as you can see, the cursor appears sometimes to be like the blue one, so that the surface is there, but it's invisible. So if we would run it on HoloLens, we will still have that mesh, but it's invisible, and we can hit the floor, for example. So we can air tap on the box, and it will be sitting on the floor. Ta-da! So we have like 2 minutes left. I don't know, maybe question and answers, I would say. Because, I mean, I can show you how to deploy it to HoloLens, but it's basically building and pushing it to HoloLens for Visual Studio. It's nothing really fancy. So let's just do question and answers, and I can show you HoloLens to whoever likes it afterwards.
So if you want to build really complex objects to put into your scene, you do this in 3D Studio? Or
Yeah. So for example, what I'm doing right now is I was given the CAD project from one of the CAD designers, which is like some kind of machinery, and I'm putting it in. I put it into a HoloLens app, and I can place that machine like in front of me. I can actually, I think I can. I don't know if I have this video. Whatever. Yeah, you create the objects in some kind of other applications. Yes. Again? Again?
Can you get a simple vector from the HoloLens?
Direction where you're looking at? Yes. Yes. It's a gaze vector. You can get it.
And you can use it in Unity like a regular vector?
Yeah.
It's not a special?
No. It's like regular vectors. Yeah. I mean, I think so. Yeah. It's gaze direction. It's called gaze direction. It's a vector. Yeah. Yeah.
3D objects can have like very complex behaviors, like door is opening.
Animations, you mean?
Yes, animations. And
Yeah.
how to interact with it? For example, you get an object from 3D Studio with some possibility of animating it. It's embedded in the object.
Yeah, it's embedded in the object, and you basically that's a Unity thing. It's not HoloLens thing. It's basically you can fire up the animation that is blended with the object.
So it's exposing some event.
Yes. Or you can create your animations inside Unity as well. Yeah. So it depends, basically. Any other question? Yes?
What is the frame rate
Again, what's the question?
When you're looking through the HoloLens, usually what's the frame rate?
Frame rate?
Yes.
Oh, the frame rate. The default frame rate is 60 frames per hour, but it's what, per second. Sorry, that would be bad frame rate. Yeah. Yeah. So 60 FPS, and well, we have to keep that. I mean, based on the performance of the application, it can drop, of course, but we should keep it like on 60.
You said it's mainly for industries, for business, and is there any, like, and you also showed some games, so what is the division of the market?
Okay.
It's probably expensive, right?
Yeah, it's the HoloLens itself, the development version costs $3,000, and the regular version, like the enterprise, cost $5,000. So looking at prices, we can assume that it's not for consumer market. But the games were created at the very beginning, where the HoloLens was released, and those were basically for showing the capabilities of the device. So it's not like for people to buy. Those games are for free, and they're just showing the things. It's for Microsoft to show, you know, how this thing works. But there are also lots of developers that are just learning the platform, and they are creating games as well, just for fun and learning.
I think according to Microsoft, they're planning to release it for gaming, because there were some videos that you were playing Minecraft in your
Yeah, I mean, there is Minecraft for this. Yeah, I mean, yes. I mean, but all of this is basically, I think, for promotion, I would say. It's not like you can, it's too expensive to expect that the regular user would just buy it like on a consumer market. Yeah?
So for a shared environment, when you program physics, do they have some special tools, or you have to treat it basically like a multiplayer environment?
More or less like a multiplayer environment.
So you have to worry about stabilization?
It's basically two instances of the same application, that one it runs on one HoloLens and the other one runs on the other one. And the first one connects to like some kind of a service, and when the other person connects to that service, the coordinate systems are being aligned, and all the holograms they have, they're also being aligned with each other. So it's all about like exchanging data on what happened in one environment to the other one, and it's all being aligned. So it's like a multiplayer game, I would say.
What is
more or
the
less.
means of communication there? Like, it's like through the same Wi-Fi, or?
Well, it's a service on some server that lives in. It communicates over Wi-Fi. Yeah.
It's built in, like the network and.
Yeah.
So obviously you just
Yeah. And HoloLens, they have Wi-Fi. Wi-Fi is because the HoloLens, the device is untethered, so there's no wire there.
So what's the battery life?
Battery life is about 2 to 3 hours active use, so it's not like very long. But you would, for example, you wouldn't like to use it like for 8 hours at all, because it's kind of too heavy. So after 1 hour, it's like you need a rest, basically. Yeah. Yeah.
How far spatial scanning is accurate?
I mean, how far you have to be from the wall to the wall being scanned, or?
How far it's rather accurate scanning?
Well, it depends. I mean, if we would tweak the number of triangles that we would like to have in our special mesh, it can get pretty decent. But the main purpose is for scanning like the surfaces or bigger objects in the user environment. There's no way to scan, for example, like a bottle or like smaller objects and detect them with special mapping. It's not the tool for that. You have to use something else. So basically, walls, chairs, sofas, like bigger objects that define our environment.
Did you have problems with performance so far?
Not yet. Not in the applications that I had. But I can assume if you, for example, import like, well, I had once when I had an object from like a Blender which had like way too many triangles, and then basically after importing it, it killed the application, because we have to. I had to lower the number of triangles, basically. Yeah. Anything else? Okay, so thank you. If you would like to try HoloLens, I'm here.